Okay, so today we are going to be going through the SL May IB Chemistry Time Zone 2 Paper 1A exam. You're ignore my cat in the background, but hopefully maybe I can mute her out in the editing of this video. And actually, this video is going to be all in one video, unlike the HL version, because SL has 30 questions. Of those 30 questions, 20 of them are the same as HL. Okay, and so I'm going to put a little link there or something to where you can see the playlist for the HL version of this. In the description, you can see a corresponding which question for the SL version corresponds to each question on the HL version. Okay, and so then you can go to that video, and in the description of each HL video, it has the timestamps for each question. So you can go to the timestamp of the question you're looking for and then watch that video instead. Okay, don't watch any of the HL videos that do not apply to you as SL students. Okay, but I'm not refilming 20 different new SL videos that are the exact same thing that I did for HL. So just go watch those. Okay. And then we are just going to go over in this video the 5 unique questions that exist. So actually, my math is wrong. Since there's only 5 unique questions, it's actually 25 questions that are in common with HL, which is new. On the old syllabus, it was only 15. Now it is 25. I don't know if that's a coincidence or not. If this is the same for the November exams, we can assume that it is a pattern. This exam, question mark? Who knows? Maybe they were feeling funky. Okay, so for this question 3, this is the first unique question for the chemistry SL exam. So this one is saying that the emission spectrum of hydrogen provides evidence for which feature of atomic structure. So this one is from an oddly specific part of the syllabus. I will put it in a screenshot here. There's also a very similar question in the specimen paper, which for paper 2, which I will also put here. And so the big thing is that the emission spectrum of hydrogen, like what we mean by that, those are those funny little, how you can correspond the little black, and then it has like the lines there, right? And it can correspond to that guy. Okay, you know how we can label this like n equals 1, n equals 2, n equals 3, and it converges at n equals infinity, right? And so whenever we're thinking about this, it's literally kind of like, well, which of these options can we label at any of these diagrams, you know? And so like the nucleus, that's not labeled in any of these diagrams. So that one's wrong. Energy levels, that is our n equals 1, n equals 2, so on and so forth. That is what those things are. So we can label it in that diagram of that hydrogen atom. Okay, and so that one is the correct answer. C and D are also wrong because those are not related to this diagram. In addition, essentially like these are like energy to ionize to go to each energy level. And so the fact that those correspond with wavelengths and frequencies are also what is showing evidence for the energy levels. And so that is essentially also that paper 2 type version of this question. So you should know both in general, because it's oddly kind of specific wording. So I would just kind of look at it, you know what I mean, and remember it. Okay, and so question 9 is the next unique question on the SL exam. And so that's one where it's saying which metal has the strongest bonding. So this is talking about metallic bond strength. Okay, and I don't know about you, but for some reason, I always kind of have a stroke whenever I'm thinking about metallic bond strength, because I'm like, wait, what affects that? Wait, hold up. Oh my God, it's been a while, right? Because like it's a very small part of the curriculum, you know? And so the best way to think about this is that the factors that affect metallic bonding strength are the same factors that affect lattice enthalpy. Okay, and so those two things are going to be the charge and the radius. Okay, technically also the number of delocalized electrons. However, that is kind of already accounted for in the charge. So I don't really consider it as an extra factor, if that makes sense. So in this, our options are magnesium, calcium, strontium, and barium. I started strontium, right? I don't know. I'm not going to check. I feel like it is. And so either way, these are the guys that are in this group 2. Okay, and it's quite literally listed in order. So you have magnesium up top, calcium, strontium, barium. Okay, so we don't have to worry about remembering them. And so all of these, since they're in group 2, they're going to have the same charge. They're going to have the same 2+ charge. So that's not going to change anything. So they all have that same thing. So we're going to look at the radius. All the periodic trends. So here's how I remember the periodic trends, right? Well, there's like the logistics, right? But then just as a memory aid, it's literally everything. So like ionization energy, electronegativity, electron affinity, all of them go up and to the right. Okay. Radius is the only one that is the odd one out. So that's how I remember radius. Radius is always going to be the opposite of all of the others. And so that's going to be increasing to right to left and then up, down. Okay. And so our radius is going to be increasing that way. And so how does our radius affect the bonding? And so this is where I like to use the metaphor of that one couple in your school that has a lot of PDA and you're like, please get away from each other. So the stronger bonding means they're really attracted to each other. They're really in love. They really love each other. Okay. And so if you have a couple that really likes each other, they're really close together. The radius is very small. So the smaller the radius, the stronger the bonding and the more attracted they are to each other. Okay. And so for our strongest bonding, we're going to look for the smallest radius. Okay. And so that one is going to be A, magnesium for number 9. Okay. Okay. So this next one, it's question number 11, the next unique question for SL. This one is quite easy. It's literally just which label shows the D block element of the periodic table. So this is just knowing which block is in each part of the periodic table, which is just based on the electron configuration, right? And so this A is where you have your S. So that is the S block, which is in fact not D. So A is wrong. B is your D block. That's where your transition metal elements are. They are in the D block. And you also have, that's where your 3D, 4D, all of those all come in. So that is the D block. Shadowin is correct. But we're also going to label the others just for funsies. And so C is where you have your P block coming in. And so that is the P block. Also making it incorrect. And then D is your often forgotten about F block. We don't have to know any of the electron configurations of anything in the F block, but we do have to know that it exists and that's where it's located. So it's always good to go over it. So the answer for this number 11 is B. Okay, and so this one is question number 14, the next unique question for SL. This one is talking about isomers and talking about which is an isomer of propanone. And so you have both the structure and the name, and both of them are showing you that this is a ketone, okay, which is very important because an isomer in general is something that has the same formula, okay, but different connectivity. Okay, and so whatever answer choice you choose needs to have the same formula, so you need to figure out the formula. So we're just going to count. We have 3 carbons, hydrogens, we have 1, 2, 3, 4, 5, 6, and then 1 oxygen. Okay, and so this is where you could just count and then see where that gets you. But also a good trick is that a lot of the functional group isomers specifically come in pairs. Okay, and so ketones, they are always going to have an isomer that is an aldehyde. Okay, the same thing applies for carboxylic acids, esters, as well as ethers and alcohols, I believe. Fact check that last one. I'm not, my memory might be failing me. But either way, ketones and aldehydes are the very classic example that commonly comes up. Okay, and so immediately in all of these, I'm going to look for an aldehyde. And if you don't remember what an aldehyde is the ones that have the carbonyl group similar to a ketone, but then they also have a hydrogen on the end. And so that immediately is bringing me to D, okay? And so at D, I'm going to check and see if the formula is the same, okay? So we have 3 carbons, hydrogens, 1, 2, 3, 4, 5, 6, and 1 oxygen. So that is right. So D is the correct answer. However, just to simulate an environment where you don't remember that, we are going to look at the formula for all the other structures just to be safe. So A, we have C, 1, 2, 3, 4. That already is wrong. Wow, we don't even have to finish that. B, we have 1, 2, 3, C3. H, 1, 2, 3, 4, 5, 6, 7, 8. Too many hydrogens. Also not good. C, we have C, 1, 2, 3. H, 1, 2, 3, 4, 5, 6, 7, 8. Same thing, too many hydrogens. And so that still leads us to D. But if you remember the trick, then it's going to help you a lot more and you can get through your exam faster, which is really important because when A and 1B are together, you want to get through 1A as quick as possible to get through 1B because 1B is harder. So, okay, so number 21, I actually looked back. I lied. There's actually 6 unique questions, not 5. So this is not the last one. So this one is saying, why does rate of reaction increase with temperature? So this is one where it not only has to be correct, but it also has to explain why. And so if we're looking at all the options, A is a higher proportion of collisions have the proper orientation. And so that is one of the options. Meanwhile, B, a higher proportion of collisions have sufficient energy. Okay. Then you have activation energy decreases and activation energy increases. So D and C and D are going to be ones that we can cross out immediately off the bat because temperature does not change the activation energy. Okay. Because temperature, like if you're drawing your Maxwell-Boltzmann distribution curve, is it doesn't change the activation energy, it just changes the proportion of the collisions with enough activation energy that is greater than enough energy that is greater than the activation energy. Sorry, my bad. Okay. And so that is also leading us to B rather than A, where A statistically is true, but it's not going to be the reason why it increases with temperature. Okay. It's not the main reason. All the other factors, that would be more likely, okay? Where the likelihood of the correct orientation, it's more of statistics. However, with the temperature is energy. And so that is going to be the main reason, is the energy and having that sufficient amount of energy. So that's going to be the main reason. So 21 is going to be B. Once again, it's not just, if it's correct, it is the reason why, the main reason why. Okay, and so this last unique SL question is number 28, which is asking about this voltaic cell, which has magnesium and silver. And so immediately it says that magnesium displaces silver from aqueous silver nitrate. And so that can immediately allow us to write a happy equation. Okay, so magnesium, solid magnesium, displaces silver from aqueous silver nitrate. So we're forming magnesium nitrate. So we would have, that would form MgNO3 2. Okay, so we're forming that. So at a ionic level, we're going from solid magnesium to magnesium cation plus 2 electrons. Okay, so that means with silver, we are going from silver cation, because it's with the nitrate at first, plus 1 electron to silver solid. Okay, so the question is asking about the silvers. We're going to zoom in on that silver equation, right? And so with the silver electrode is, first we need to determine if it's being oxidized or reduced. So our oxidation state of Ag plus is +1. Our solid silver is 0. So our oxidation state is decreasing. Okay, so that means that this is a reduction. Okay, I always like to remember the NOx, red cat. Okay, so red cat means that this is happening at the cathode. Okay, so the silver electrode is the cathode. So we can go on over cathode, take out B and V out of the running. In terms of the sign, this is where I just remember it because CAS feels positive to me, but turns out there's actually no linguistic relevance for that. Don't know where my brain got it, but either way, in terms of the theory, is whenever you're thinking about it. So in terms of how this cell is working, right, is you have your magnesium solid that's falling off to form those Mg2 plus, and then those electrons are moving over to the silver to then be fed to the silver cations to form the silver metal. Okay, and so the electrons are traveling from the Mg, which is the anode, because the silver is the cathode, so that's the only other option, to the cathode. So the anode to the cathode. And so since the anode is the source of the electrons, electrons are negative. So the anode is negative. Meanwhile, our cathode is attracting the electrons. There has to be a reason they're going over there, right? And so the only reason would be if they're attracted. And so that means that this has to be positive. Okay, and so that means that that sign is positive, which makes the answer to this one A. And that is all of the unique SL questions. Please go look at the HL videos for all of the other ones that are in common, because once again, I'm not refilling that. And good luck.